Welcome to the internship program. I am Shubham Gupta from NextGen AI Frameworks Pvt Limited. I have 14 years of work experience in the fields of artificial intelligence, software development and robotics. In this session, I will give you introduction to unsupervised learning and tell you the techniques used in unsupervised learning. In the supervised learning, what we did was we give the text, we give the output also, which is called label. This is not spam. Okay, and u1, this is spam. Now what will happen is we will not be having labels here. We will only be having the input here, no labels here in unsupervised learning. There we already gave the output, but here we don't have it. This is unsupervised learning. Okay, so then I will start with this unsupervised learning and try to give you practical examples so that you will understand the difference. So in week 5, what we will be seeing is K means hierarchy clustering, dimensionality reduction, PCA, TSNE, anomaly detection, and then this hands-on project, customer segmentation. So this is what week 5 is. I have created this article available in blog section. If you open the blog section, clustering algorithms, after opening this article, this is how it looks like. So I have included some examples to tell you how it works. First I will run the code so you will understand the output. So let's see. So first thing will be to activate the virtual environment. Select the interpreter so that Visual Studio can do code completion. Then I have included the libraries required here. You can just copy paste and run the code. Now let's see. I will run this k underscore means. So this is the first example. Remember this word clustering. It distributes the data into these clusters like this, and when you view these clusters you will make some sense out of the data. Again I will tell you, remember this one word clustering. It will distribute the data in this format so that you can understand the types of customers. For example, you have or their interest, different interest. So I have not given any output label. What it will do is gather all the data and then generate this chart. So this is first example, K means. Let's see the other one. You see this hierarchy here. This is how this chart looks like. This is again clustering. I will tell you what clustering is and give you more real world example, but I started with these charts because so that you won't get confused with the unsupervised learning. Here we will be dealing with these kind of outputs. So I shown you k-means and this hierarchy. I have created these two examples only today, so I will be showing these and in the next session I will be covering rest of them. So I will move slowly so that you will understand what I am doing. So these kind of plots we are looking at. Now let's see. So clustering algorithms and dimensionality reduction techniques. These are essential techniques in machine learning, aiding in understanding large data sets by grouping similar data points. So as I have shown and in the example k-means, if you remember, see in the k-means, see, okay. So let's read the theory and look at this. Grouping similar data points and simplifying data structure. So from the complex data we can group the similar data points. These similar data points can be customers or products or services, so we can group them together automatically. So suppose on large platforms like Amazon, if you they have I think millions of products, so how can they cannot manually do the things, so they can run these kind of algorithms to automate the task of grouping the similar data points. So this is unsupervised learning. And then let's look at the clustering algorithms. So first one is k-means clustering. Read these simple words: partitions the data set into k distinct clusters. So small parts, big data sets, small parts. This is k-means clustering. Partition the data set into k distinct clusters. So big data set into small data sets, then they will be termed as k distinct clusters. And you don't have to worry too much about implementing it. Again, this will be the simple code. So everything already implemented in Python. See, this is how k-means is being used from sklearn.cluster k-means. That's it. So don't worry about the code, just understand the concept. So mostly where it is mostly used, customer segmentation in marketing. Customer segmentation in marketing. So companies, if they want to know which customers, if they are launching a new product and they want to know which customers they can target, their own customers. So if they have 1 million customers, so who should see the new product or service? So this will be the perfect example here: customer segmentation in marketing. So scenario: a retail company wants to better understand its customer to create targeted marketing strategy. Targeted, see, this means this is a huge term in marketing, because if you target wrong audience, then you will lose crores or millions of rupees if you target wrong people for the marketing. So remember this for targeted things. Company collects data on customer demographics, example age, income and purchasing behavior. So how frequently they purchase costly item, or they spend medium, or what is their total spending capacity. All these things can be taken out from the data, and based on that data they can be grouped together. So k-means clustering can be used to segment customers into different groups based on their buying behaviors and demographic features. So these features, what they means is, so if most of your customers are from, for example, Delhi, Maharashtra, or from Kerala, for example, so this is how You can cluster your data on the base of demographics or buying behavior or such features like that. So for example, clusters might include high spending customers. So high spending customers, occasional shoppers. So for example, some company, or you already know about big billion days and all things. So occasional shoppers, or buying or budget conscious customers. So what they will do is they will try to buy the product on the best price. So for example, some specific laptop now launched recently in the market, they will look for the best offer. Or for the iPhone, for example, the best time to buy the iPhone. So budget conscious customers, you can get all these informations from these kind of projects, unsupervised learning. So based on this, company can tailor its marketing strategies and promotions to meet the needs of each customer group, improving customer satisfaction and sales. So this is the basic first basic example of this K-means clustering. Let's see image compression. You already have seen this problem in real world. Whenever you buy a phone, digital camera, or on computer, if you save the images, if you have large images on your computer, then your storage will be used very fast. So for example, you can see I don't even have space in now C and D drive because I have created many projects. So what I'm talking about is the situation of images. So you already know in the latest phones 10-20 MB of images are being created. So whenever you click new image, then it will be of for example, in Samsung high ranges phone, then they have 15-20 MB images, high resolution images, and they require lot of memory. Second example is if you have seen the iPhone. So whenever you click the photo, they have a different format which they use to store the images, and I think it is HEIF. Yes. So this is the format iPhone is using. So whenever I click images from iPhone, I have seen the images 2 or 3 MB with the same quality. But the thing is, it is not that detailed image, but the colors it contains are almost same. But the thing is, the size is small. This is the again example of K-means. So in digital imaging, storing high resolution images requires lot of memory to reduce file size, and image compression algorithm is needed while maintaining visual quality. Application: clustering is used in image compression by clustering the pixel values of an image into K clusters. I will again tell you what pixel is. I told in previous sessions also, each dot on the display will be termed as pixel. More the pixel, better will be the resolution of the screen. This is what pixel is in the world of computer. So each pixel is then assigned to the nearest cluster, reducing the number of unique colors in the images while preserving the overall appearance. So the image that you take 20 MB and the image 1 or 2 MB will look like same. So what will it do is skip some pixels values, skip some pixel values which are not important and keep the important values. So what will be the benefit doing this? This reduces the amount of memory required to store the image while retaining visual quality, making it useful for efficient storage and faster image transmission on website or apps. So this was just for one example. There are many examples like this. So image compression is the field you will be looking for unsupervised learning. I will continue this session in next video. See you in next video. Have a nice day.